Here is your review for the U substitution test. What you should be looking for is always what's on the inside, turn that into a U. Well, in this first one, we really don't have anything on the inside, so we can't turn anything into a U. What I do notice, though, what I should look for next, is that one part should be the derivative of the other. So, if I had sine, I took a derivative to get cosine. So, that means that I make U be my sine of x, which means du, just take that derivative, is cosine of x, and we keep this dx term on the end. That means when I solve for dx, I would get dx would equal, du over cosine of x. So I'm going to rewrite this integral now. I called sine of x my u. Cosine of x I didn't change. And then dx is equal to du over cosine of x. What I should notice here is, like always, something should cancel out, which it does, and it makes my integral a lot easier, the integral of u du. I now need to take the antiderivative. I have not taken it yet. That's the main concern that you're going to have, is you'll forget to do that. The antiderivative of u is u squared over 2 plus c, and then I can't leave it in terms of u, so I change it back into my u equals sine of x, so this would be sine squared of x, or sine of x squared, over 2 plus c. Now, there's actually a different combination you could have done. You could have made u be cosine here, which would have made du equal to the negative sine of x, making dx would then equal du over negative sine x. Things would have worked the same way. If you'd done that way, you would have had the integral of u, and then you would have had a negative du in that case. So you would get negative u squared over 2 plus c, negative cosine squared of x over 2 plus c. So there's two different methods that you could have actually done for that first problem. Either one's going to work just fine. Both of these are the correct answer. So I guess I ought to get into the habit of starting to box our final answers. All right, number 2. U should be the part on the inside. Well, even if this parentheses here might try to confuse you, this is a big part on the inside. X to the 4th plus 10 should be your u, because your du should then be part of the other portion of this integral, which is the 2x cubed, which this would be a 4x cubed dx. So that should work out nicely. I'm going to solve for dx and get du over 4x cubed. So rewrite the integral. I've not changed the top, so I'm keeping that as 2x cubed. I changed the bottom into u to the 6th, and then dx I said is equal to du over 4x cubed. From there, I'm going to rewrite based on things that cancel. My x cubed should cancel, and I have a 2 over 4. That can reduce to 1 over 2, and I bring those numbers onto the outside. And now the integral would be of 1 over u to the 6th du. I don't like the exponents in the denominator, my variables in the denominator, so I'm going to bring them to the top by making it a negative exponent, so u to the negative 6th du. I still have not taken my antiderivative yet, so I will do that now. Keep the 1/2 in front. This will now be u to the negative 5th when I add 1 to the exponent, divide by my new exponent, plus c, and now just simplify. I'm going to have 1 over negative 10, or negative 1/10, and then I don't like u to the negative 5th. I need to change it back in terms of x. So plug in back in for u, so x to the 4th plus 10 to the negative 5th power, plus c. And there's your final answer. You could, if you want, make it, you'd be negative 1 over, you can bring this back down to the denominator, x to the 4th plus 10 now to the positive 5th. If I said to get rid of all negative exponents, either one of those is a perfectly good answer. All right, next problem. In C here, well, I should first notice there's nothing on the inside. There's no part that's really a derivative to another where things would cancel. What I should even be checking before that, can I take this derivative immediately? Well, I can kind of do our little heart problem and see if I can simplify this, which I can. I can say, well, 3x squared over x would just be 3x. Square root of x over x, well, this is, remember, x to the 1/2 over x to the 1st. Subtract those exponents, and I would have x to the negative 1/2 power dx. So I don't even need a u substitution because I can do this integral immediately. This will become 3x squared over 2. This will become x to the positive 1/2 divided by 1/2. And then just simplify. So I'd make it 3/2 x squared. I'd make this 2x to the 1/2, or 2 square roots of x, plus c. So either one of these answers is a perfect, good final answer. All right, in number 4, very clear what the inside should be. I can't take this integral immediately, so I will set u equal to 10x plus 9. So that means du will equal just 10 dx. So this should be an easy conversion. Dx will equal du divided by 10. So rewrite my integral now. Integral of, now it's just the square root of u, because I changed that inside to u, and then I made dx into du over 10. I have a 10 right here. It's on the bottom, so I pull it out as 1 over 10. The integral of, I don't like the square root of u, I'm going to call it u to the 1/2 power du. Still, I have not taken an antiderivative yet, so I'm going to keep the 1/10 in front. U to the 1/2 will become u to the 3/2, divide by my new exponent 3/2, plus c. And as a reminder, the du and your integral symbol only go away once you take the antiderivative. All right, so I can rewrite this. Instead of dividing by 3/2, I'll multiply by its reciprocal, and then simplify it from there. So it would be 2 over 30, which would reduce to 1 over 15. I don't like u, I got to turn it back into x, so it would be 10x plus 9 now to the 3/2 power plus c as your final answer. All right, now we got 2 with definite integrals here, and nothing fancy going on here. What I'm going to do, first say u is going to equal my inside, 2x squared, or 1 plus 2x squared, I'm sorry. Remember, use the entire inside. Du will equal 4x dx. So that means dx will equal, when I solve for that, du over 4x. So I'm going to first solve with the method of changing the limits of 0 and 1. So first off, I didn't change my x. This part became u to the 5th power, and dx we said became du over 4x. Now let me change my limits here. When x was 0, that means if I plug in 0 here, I would get u is equal to 1. When x was 1, if I plug that in, 1 squared is 1, times 2 is 2, plus 1 is 3. So my new limits are 1 and 3. I should have these x's canceling out, which they do. I should be left with the integral from 1 to 3 of u to the 5th du. And I had this 4 on the bottom, so I'm going to put a 1/4 out in front for this integral. I now need to take the antiderivative. So keep the 1/4 in front, and I'm going to have now u to the 6th over 6 as my antiderivative, which I'll evaluate at 1 and 3. I'm going to simplify if I can first, though. So to do that, I can multiply these numbers on the bottom, get 1 over 24, and that leaves me with just u to the 6th, which I'll evaluate from 1 to 3. So all I have to do from here is I need to just plug in these values. Well, when I plug in 3, u to the 6th becomes 729. 3 to the 6th is 729, and it's over 24. So I'm just going to do that right there. And then 1 to the 6th is 1 over 24 as well. I take these numbers, I subtract them, I would get 728 over 24, which I could leave it just like that, or I could reduce that if I can, which would become 91 over 3, or your calculator would say like 30.3 repeating. All right, now your other option here is, if you don't like changing the limits, well, I would have gone through the same process. I would have just said, I don't know what these limits are. Once I got to this point right here, I would then say, okay, let me change it back into my original. So instead of u to the 6th, I would make it back into 1 plus 2x squared, all to the 6th power. Now I can plug in with my original limits of 0 and 1. Well, guess what? Nothing's going to change here, because if I plug in 1, 1 squared again is 2, or 1 squared is 1, I'm sorry, times 2 is 2, plus 1 is 3. 3 to the 6th is again 729, and then it's divided by, we had that 24 out in front, that 124. Same here, if I plug in 0, well, 0 squared, that becomes 0, plus 1 is 1. 1 to the 6th is 1, so again I have 1 over 24. Again, I subtract them, and I'm going to get 728 over 24, or reducing it again to be 91 over 3. So either way, you should get the exact same answer. And number 6, it is the same setup to begin with. I'm going to start by starting with my u and du. So first, u is my inside, x squared plus 1, making du 2x dx, which makes dx would equal du over 2x. I need to try to simplify then. Again, I'll change my limits first. If I plugged in x equals -1, that means I would have 1 squared, -1 squared is 1, plus 1 is 2. U is 2. Same here at the top. When I plug in 2, 2 squared is 4, plus 1 is 5. So my new limits are 2 and 5. I didn't change my top. It stays as 4x. My bottom now will be u squared, and dx is du over 2x. And I should have my x's cancel, which they do. I have 4 divided by 2, which means I'll pull out a 2 to the outside. So 2 and 5 is my limits again, and I'd be left with 1 over u squared du. I don't like the u squared on the bottom, so I'll bring it to the top by making it a negative exponent. And this is something I can take my antiderivative of. So I will do that right now and get 2 out in front. This would be now u to the negative first over -1, which I'll evaluate at 2 and 5, but I'm going to simplify first and make it -2, and I'll put this u on the bottom because it's to the negative first power. So -2 over u is what I will be evaluating at 5 and 2. So when I plug in 5, I would get -2/5. When I plug in 2, I would get -2 over 2, which is -1. And those numbers I need to subtract. And when I subtract them, it means plus a positive. It should give me 3 over 5 as my answer. And again, I can do the same like I did up here. I would have gotten to this step right here. But instead of using these new limits, I could have changed back into my original. So -2 over, instead of just u, I would put in my x squared plus 1 and plug in my original limits of 2 and -1. If I plug in 2, on the bottom I get 2 squared is 4, plus 1 is 5, so -2 over 5 again. If I plug in -1, I would get -1 squared is 1, plus 1 is 2. So -2 over +2 would give you a -1. Again, I subtract them, and I will get 3 over 5, yet again, making that plus a positive. So either way, you should get the exact same value. All right, and a little sneak peek at your bonus, which I'm sure you don't mind. So, in this one, you would set u equal to the inside, x minus 4. That makes du equal to dx, which is just nice and easy. So, when I would simplify this, it would be x times the square root of u, and I just have du because dx equals du. Notice, though, my x doesn't cancel out. I haven't had a chance to, to cancel out anything to get rid of all the x's. Well, what I can do, though, I can take this and solve for x. Well, x would equal u plus 4 if I solve for x in that equation. So I'm just going to plug that in now. So the integral of u plus 4 times the square root of u du. Remember, square root of u is the same as saying u to the 1/2 power. So I can distribute this through. U times u to the 1/2 would be u to the 3/2 power. 4 times u to the 1/2 is just 4u to the 1/2. I still have not taken an antiderivative yet, so that's what I need to do now. So this would be u to the 5/2 divided by 5/2. This would now be 4u to the 3/2 over 3/2, and then plus c. So I'll just simplify from there. 2/5. I don't like u, so I'll change that back into x minus 4 to the 5/2 power. This part will become, it'd multiply by 2 over 3, so it would be 8 over 3. And again, I don't like it in u, so x minus 4 to the 3/2 power, and then plus c at the end because it was indefinite. There you have it, your u substitution. Just make sure always start on the with inside being u, and if there is no inside, first check if you can do it just with basic antiderivative properties, and if not, look to see, like in the first one, if one part is the derivative of the other. Best of luck.